Let's look at some step-by-step examples of simplifying exponential expressions. To simplify an exponential expression, that means that we need to remove any parentheses by distributing outer exponents. We need to rewrite terms so there's no negative exponents in our answer. We need to combine similar bases using exponent rules. And we need to fully simplify coefficients. So if there are any powers of coefficients, we need to multiply those out and write our coefficients in reduced terms. There's often more than one way to approach an exponential expression, and so you can use any of the rules, and as long as you apply the exponent rules consistently, you'll always arrive at the same answer no matter which order you applied the rules. And so we'll see sometimes there is a choice of how to simplify these expressions. Let's look at the one on the board behind me. Usually how I begin is if there's a parentheses, I start by distributing the outer exponent. Remember, that happens through multiplication according to the power rule. This exponent of 2 needs to multiply to everything inside, including the coefficient of 3. Now, we're not going to multiply 3 times 2. We're going to take 3 to the power of 2. So let's rewrite this. I have negative 3ab squared over 3 squared a to the 4th b to the negative 4. Okay? I'm going to evaluate this coefficient, and I'm going to move this negative exponent, rewrite this as a positive exponent. So I have negative 3ab squared over 9a to the 4th. Let's separate out that b to the negative 4 in the denominator. 1 over b to the negative 4 is the same as b to the positive 4 over 1. So we have negative 3ab squared over 9a to the 4th times b to the 4 over 1. Now let's combine some terms through addition. So I have b squared and b to the 4th. That gives me b to the 6th. We have negative 3a b to the 6th over 9a to the 4th. There are two more things that need to happen. First, these coefficients can be divided by 3. And second, we can eliminate a term of a. If you use an exponent rule there, that's subtraction on the exponents. If I subtract in this order, 1 minus 4, I'll have a to the negative 3 in the numerator, and then I need to remove the negative exponent. If I subtract in this order, 4 minus 1, I'll have a cubed, a to the positive 3, in the denominator. So let's go with that. First, I'm dividing these by 3, so I have negative 1 over 3 for these coefficients. Then I'm subtracting in this order, so I have a to the 4th and a to the 1st, that gives me a cubed. And finally, I have this b to the 6th in the numerator. So my final result in simplified form is negative b to the 6th over 3a cubed. Let's look at a second example. Again, I'm going to start this one by distributing outer exponents in order to eliminate these parentheses. So remember, you're distributing the exponent on the outside times all of the exponents on the inside. I'm not multiplying 4 times negative 3, but rather I'm multiplying the exponent on the 4. It's 4 to the 1st times negative 3. So that becomes 4 to the negative 3, x to the positive 9, y to the negative 6, times, here it's 2 to the 1st times 4, so that's 2 to the 4th, x to the 1st times 4, x to the 4th, times y to the negative 12. Now I have some negative exponents here, and all of this is in one long multiplication. You can imagine a denominator of 1. Let's eliminate the negative exponents next by rewriting those terms so that those terms go to the denominator. So remember, 4 to the negative 3 is the same as 1 over 4 cubed. So I have 1 over 4 cubed times x to the 9 Here I have y to the negative 6, so that's like 1 over y to the 6 times 2 to the 4th times x to the 4th times 1 over y to the 12th. So all of these terms with negative exponents, the effect of applying the negative exponent rule is that those terms with negative exponents moved to the denominator and became terms with positive exponents. So I went from 4 to the negative 3 in the numerator to 4 to the positive 3 in the denominator, and so on. Let's see how we can simplify now by combining any like terms. When I look at the numerator, I have x to the 9th and x to the 4th. I'm also going to multiply out this coefficient. 2 to the power of 4 is 16. So let's start there. 2 to the 4th is 16. X to the 9th and x to the 4th gives me x to the 13th. And that's over 4 cubed, that's 64. And y to the 6th times y to the 12th gives me y to the 18th. I'm adding those exponents. The last step here is simply to reduce this fraction in lowest terms. 16 over 64, those are both divisible by 16. So this becomes 1 over 4. And so my final result is x to the 13th over 4, y to the 18th. The exponent rules give a structure that applies to expressions even when we're working with abstract amounts. So if I want to simplify a to the n, a to the 5n over a to the negative 2n, I simply follow the exponent rules we've already established. First, in the numerator, I have a to the n times a to the 5n. I know I'm supposed to add those exponents. So that gives me a to the n plus 5n over a to the negative 2n. That's a to the 6n over a to the negative 2n. The second rule I might apply is that of subtraction. I have a choice here. I can apply the negative exponent rule, or I can apply the quotient rule. I'm going to use the quotient rule to subtract these two. So if I use the quotient rule, I have a to the 6n over a to the negative 2n. That becomes a to the 6n minus negative 2n. And that simplifies to a to the 6n plus 2n, which is a to the 8n. All right, so even though we're working with another layer of abstraction here, we can still use the exponent rules to simplify our expressions.